So, a couple of episodes ago, we were talking about how you can use space telescopes to see in the X ray and look at supermassive black holes. But they're not the only things that give off X ray, right?
Yeah, stuff again that I used to work on, supernova, exploding stars, also give off X-rays. And what's kind of cool about them is the X-rays change on a human timescale, on days or months or years even. So we have one of my old friends from the supernova community, Professor Raffaella Margutti, assistant professor at Northwestern University, who's going to tell us about looking in the X-rays at exploding stars and weird stuff that pops up in the night sky and then disappears in the X-rays, or stays the same, and they don't understand that either. So. Welcome, Raph. Thanks for coming.
Yeah, thank you for having me. Yeah, so stars, when they explode, they can produce X-rays through many different mechanisms. And so the first thing actually that a star produces when it dies is a very short burst of X-ray gamma ray emission. And that's the very first signal that reaches observers, or is supposed to. And actually, we just saw it once. For a supernova in 2008. That's the only shock breakout, we call it, a shock breakout signal we've ever seen from a supernova so far. But after that, if you wait a little bit, the same supernova can start interacting with the environment. So stars explode in very, very thick and polluted environment, and interacting with this environment, the star produces X-rays too.
So that shock breakout, how long does that last? It's really short, right?
It's really short, and it brings important information about how big a star is. So the bigger you are, the longer it lasts. So if you're a big star, it would last hours. If you are like a star like the sun, it would last minutes.
Yeah, so we're talking about hours to minutes. That is incredibly fast for anything in astronomy.
So, how do you react quickly enough to see something on that shorter timescale?
So the real answer is that as of now, in the X-rays, you just need to be lucky and be already pointing there in the sky. In the gamma rays, instead, we have instruments that can view a bigger portion of the sky, and then they can get a trigger. We call it trigger, and then the spacecraft can view. And Swift is the NASA spacecraft that can do it as quickly as possible as of now, and it can do it in 60 seconds.
So you mentioned Swift. That's one of the NASA spacecraft, that space telescopes that you use for this kind of game. What other space telescopes and facilities do you use to look at X-rays and gamma rays, these really high energy coming out of exploding stars?
Yeah, Swift is the NASA mission that is the closest to my heart, because I started as a grad student working on Swift. However, now I grew up and I use other things too. So I use Chandra, the Chandra X-ray Observatory would be like a large mission, NASA mission. XMM Newton, that is a partnership with ESA, so ESA and NASA. NuSTAR is the last one that joined the family, and it can observe on a little bit higher energies. We call it hard X-rays. And this is the mission that is giving us a lot of surprises right now.
So what are some of the surprising things that you found recently?
Yeah, so consider that NuSTAR was not really thought to be particularly useful for young supernova explosions. It was designed to tell us a lot about old stars that exploded, like explosions that happened centuries ago, but not things that just happened. However, a couple of years ago, well, it's more than that. It's in 2014, so it's 4 years ago. Okay, yeah. So we managed to repoint NuSTAR to a star that was 100 days old, and we found a very bright signal. And that was a surprise. We did not expect that. And then after a lot of thinking and a lot of data coming all the way from the radio to the gamma rays, we understood that star re-brightened because the shock, so the explosion, smashed against a wall of material that the star deposited in the environment before dying. So that would happen. So that was a huge surprise. Now we know that that can happen, and it seems like normal. But at that time, it was like, I don't know what it is.
Yeah, these stars, we've talked to a couple of people talking about dying stars, belching off, burping off material, and you can get these shells and stuff running into each other and produce radio and infrared and these X-rays that you have looked at. So yeah, really cool stuff coming from all different kinds of observations. So you mentioned to us before we started recording that you had a brand new observation from New Star that was very interesting, and you haven't gotten much sleep because you've been poring over the data and trying to figure out what the hell is it telling you. So could you tell us a little bit about what's going on there?
Last week, we got an alert about an explosion. Well, we thought it was a supernova explosion that, however, instead of taking 2 weeks or more to reach peak luminosity, it took 2-3 days, and it was already super bright. And that was by itself very, very interesting. So we saw something cool in the sky. What do? You're an observer. You turn every possible instrument you have access to. That's what we do. So I thought, okay, NuSTAR can, I knew that NuSTAR could detect such a supernova because I had other information from other missions. And I said, okay, I designed my experiment to see what the star was doing over there. And in my thought, the flux, so the energy coming from the star, should either be stable or declining. Was very happy that I scheduled these observations, and then on Sunday morning we got the data down on Earth. I started analyzing them, and nope, the flux is going up. And I don't know what I'm looking at. So to be honest, we don't know what is going on there. We have no clue. So at this point, I'm not even sure it's a star that exploded. It's literally wild. Yeah, and we're gonna be keeping observing. So because the only thing we can do is, well, I don't know what it is. Let's get more information. So yeah, stay.
That's great. That's the best, I think, some of the funnest, best kind of observations is the exact opposite of what you expect, like you were saying.
This is going to be one of those things that leads to one of those headlines that says astronomers baffled by brightening star.
Well, you'll get more data and you'll write papers, and then 2 years from now when we talk to you again, they'll be totally normal, and whatever this is run of the mill, and there'll be a whole class of them and they'll have a silly name, and there you go.
Yeah, my first reaction was, well, you're up with no sleep. You made some silly mistake in your data reduction. That was my first reaction, and the entire world is waiting for me to put out this telegram, and I'm not ready.
You don't want to be like the people who put out the telegram alerting everyone to the existence of Mars. That would be embarrassing.
So X-rays tend to be pretty faint and only come from, certain flavors of supernova. So it's really not a hugely studied field, but, you got into this field. This is where you're working, where you've made your bread and butter over the years.
I kind of switched field when I moved from graduate student to a postdoc, and everybody was telling me that studying X-rays, studying supernovae in the X-rays was not a particularly good idea, because supernovae are not bright in the X-rays, and it was sort of an old field and there was no real potential for evolution in the field. And I'm glad I was able to make my living on that. So there is actually more that we can do than what people think about X-rays in supernovae.
All right. Well, in a couple of years, when you've got, all the data on, whatever the hell this object is, and you totally understand it perfectly in the X-rays and all the different kinds of light, come back and tell us what's going on here. And we'll say, you broke the news first here on Three Body Problems. So thanks for coming out, Raph. Appreciate it.
Thank you so much for having me.